Namaste everyone, this is Srikanth. Welcome to my channel CADiMate, where we give life to the boring subjects using CAD technologies. In this video, we'll be solving a problem on kinematics of machines, which appeared for students from OU in December 2017 supplementary examinations. You can see the statement here clearly. I have noted down the given quantities over here on the diagram itself. If needed, you can pause the video and write them down yourself. So let's proceed directly to solve the problem. In every epicyclic gear train problem, you will have to draw the table. Epicyclic gear train, you need to draw the table. And the table always starts with the arm. So in this case, if you see, link 2 is working like the arm. So when I write the speed of the arm, I have to write it as N1. Sorry, that is N2. As I explained before, after the arm, we have to go straight away for the sun. Now sun here is the gear tree. So sun, I'll have to write N3 as the speed. Now the sun gear, you can see it is connected to a planet gear. So next comes the planet gear, and the number for this one is 4. So I'll have to write the speed as N. And finally, the planet gear 4 is meshing with the outer annular ring, which is called the gear 1. So annulus, we will call it as N1. Now once again, we have to find the formula for all the speeds in 3 steps. In first step, we will consider the arm to be at rest, and we will give 1 rotation to the sun. And according to that, we have to find the rotations for the planet and the annular wheel. So we can see here that the gear 4 is meshing directly with the gear sun. So N4 by N3 is the formula we'll get, and because they are externally meshing, the formula is going to be minus T3 by T4. Now you can see in the table that N3 is undergoing just 1 rotation, so this becomes 1, and we got the value of N4 to be minus T3 upon T4. So minus T3 upon T4. Next, we need to find the formula for annular speed. So for that, we have to see which gear it is meshing with. The gear 1 is meshing with gear 4. So we have to write the relation between those. So N1 by N4 is the relation we get. And because they are internally meshing, the formula is not going to include a minus sign. But of course, the number of teeth will be in opposite order because they are inversely proportional. So this implies that the speed N1 will be equal to N4, which we can substitute from here, that is minus T3 by T4 multiplied with this value as it is, T4 by T1. Now we see that T4 is getting cancelled and we are left with T3 upon T1. So this is the number of rotations turned by N1. So T3 upon T1. This completes our first step. In the second step, instead of just 1 rotation, we will be providing X rotations to the sun. This will remain at rest. This becomes X, and all other values will be multiplied with X. So this becomes X times T3 upon T1. In the final step, we'll have to give Y number of rotations to the arm. So when we do that, Y will be added to all these terms. So 0 plus Y becomes just Y. X plus Y becomes just that, X plus Y. And here when we add Y, I'll just put the negative term in the second place, and T3 upon T4 will remain. And here we'll get Y minus X times T3 upon T. So these are the formulae we'll be using for the speeds. Now let's see from the problem what are the speeds given to us. We have been provided that the gear 1 is fixed here. So the ring is fixed. That means the gear 1 will have its speed equal to 0. So that means N1, which is Y minus X times T3 upon T2. So this will be equal to 0. The second speed that is provided to us, 1200 RPM, belongs to the sun gear, which for us is N3. So N3 value, the formula for which is X plus Y, is actually equal to 1200. Now we need to solve these two equations to get the value of X and Y, and that will allow us to find all the speeds. So in the question, we have been provided the T3 number of teeth as well as T1 number of teeth. So let us substitute them here. So we get y minus x times T3, which is 30, divided by T1, which is 120. So this is equal to 0. So cancelling these, we get equation y minus x by 4 equals 0. So this is our equation number 1. Now let's go to the other equation. You can see this is almost very simple already. So this we'll call it as equation number 2. Now we have to solve these two equations to find the value of x and y. So let us just go ahead with the y value. It will be equal to x by 4. So these value let us substitute here in this equation. So we get x plus x by 4 equals 1200. So this gives us 5x by 4 equals 1200, which gives x equals 1200 into 4 upon 5. Let us calculate this. So 1200 into 4 by 5. So this is giving us 960. So that means the value of x here, is 960. And the value of y we can get by substituting the value of x here in this equation, and that gives us x by 4, that is 960 by 4, which is 240. So now that we have the value of x as well as the value of y, we can find all these velocities. So the velocity of arm is just y, which means it is just 240 r. But that's not something which is asked in the question. In the question, he is asking the velocity of the sun gear, which is this one over here. So this is the formula we have to use. So the velocity of sun gear, which is n3, equals x plus y. And we just need to substitute both the values of x and y. So 240 plus 960. That gives us 1200 once again. So the output shaft will be rotating at same speed as the input shaft. And since there is no change in the sign as well, the plus has remained plus throughout, which means all the directions are clockwise in nature, just same as the input direction, which is clockwise here. So that's it for now. In future, we will take up some more problems and we will be solving them. If you want more updates, just subscribe to our channel. And of course, hit like button if you like the video, share it with your friends so that they can take the advantage of these videos as well. Thank you.